Okay, so the first lesson talks about sampling methods, but before we get into those, we even have to know just what a sample is. So our two kind of things that we're going to start with are population versus sample. So a population would be the entire group of people or things that I'm talking about. So let's say I want to figure out something about a school, then my population would be every single student in the school. Okay, so the population is everybody. Individuals. Okay. So that's a population. And when we have a population, if I want to figure out stuff about it, one way I can do that is I can conduct a census. And a census is when I'm surveying all the people in my population. So I want to talk to every single person. So if I was conducting a census for information about our school, I would have to ask every single student in order to get this information. Okay, so that's a population in a census. But there are sometimes where it really doesn't make sense to conduct a census. Like at our school, I don't have time to ask every single student a question. There's way too many of you guys. So instead of looking at the population, I would look at just a sample of the population. So a sample comes from our population, but it's just some of those people from the population. We don't talk to every single person. So it's only some of the people in our population. Okay, so we can either look at the whole population or just some of them. And when we just look at some of them, there's different ways for us to pick that smaller group. So that's where those sampling methods are going to come in a few minutes. We have different ways to pick our sample, but when we pick our sample, we want to try to do a good job of creating a little mini version of our population so that it just looks like kind of the same group. We don't want to just pick from one set of the people in our population. Okay, and when we figure out information, either asking the whole population or just asking a sample, then we could take that data and start figuring out numbers from it. So that's where these other two vocab words come in. A parameter is a number, and it's going to summarize something about our population. So we have to ask every single person in order to get a parameter. Okay, we conduct a census, and when we conduct that census, we calculate our numbers. Those numbers are parameters. Okay, so a parameter is for a population, PP, haha. Okay, and then if we only talk to a sample, then when we get that number, it's not called a parameter anymore, it's called a statistic. But a parameter and a statistic basically are the same thing. It's just that a parameter describes every single person, and a statistic is just describing that sample that we pulled out from the population. Okay, so that's just the general idea, the difference between population and sample and the information we can get from those groups. Okay, and then like I said, there's different ways we can create our sample. So we have 6 different sampling methods that we're going to talk about. Some of them are better than others, and some of them are going to be more realistic than others in different situations. It just kind of depends. Okay, but like I said, our real main goal when we're creating a sample is to create a little mini version of the population, because if it doesn't really look like our population, we're not going to really be able to use it to predict stuff about our population, because our sample doesn't really look like the population. So we have to be kind of careful when we pick our sampling methods. Okay, so these are our 6 sampling methods. The simple random sample kind of just tells you exactly what it is. It's a simple random picking of people from the population. So I look at a list of the whole population and I just randomly pick people from that list. And when we pick that way, everyone in the population has an equal chance of being picked. So going still with our school idea, if I had a roster of every single student in the school, then I could just get like a computer program to randomly pick 100 people from that roster, and then I have a simple random sample of the students in the school. Okay, a self-selected sample, again, the name kind of tells you what it is. People in the sample select themselves to be part of the sample. So this is when people volunteer. It's like if I sent out an email to every single student and I said, hey, anyone who wants to, you can do this survey. You have to volunteer to be part of that sample. Okay, the next one is a convenience sample. This one is convenient to the person who's trying to conduct the survey or like put that sample together. It's just selecting people based on how accessible they are to me. So like people who just kind of happen to be in a certain place when I need to talk to them, that would be convenience sample because it's convenient for me to just pick those people. So like maybe I just pick all the people who happen to be in front of the school at 7 a.m. Then that would be a convenience sample because I'm just picking people that are kind of there when I need them to be. They just kind of happen to be there. So that's a convenience sample. Okay, then we have a systematic sample. A systematic sample follows a system. Okay, so we use some sort of rule to pick the sample. So this is a little different from simple random sample because a simple random sample is random. We're randomly picking from the entire population. Systematic, we're following a rule. So the most common one for this would be like if I pick every 7th person on my roster. So same kind of as the simple random sample, I'm looking at a roster of the entire school, but instead of just using a computer to randomly pick, I'm going to pick every 7th person. That would be a systematic sample. Okay, and then these last two are a little confusing because they seem very similar to each other. These ones are very similar to each other. Both of them have to do with dividing our population into groups. Okay, so both of these, kind of the first step is to divide it into groups. So like for a school, the most easy way for us to divide it into groups would be like by class. So freshman, sophomore, junior, senior. Okay, so both of these methods of sampling kind of start from the same spot of I would just look at, okay, I have a list of freshmen, a list of sophomores, a list of juniors, and a list of seniors. So here's where the difference comes in. If I'm taking a stratified sample, then I am taking from every single group that I have in my sample. Okay, so I'm going to pick maybe like 20 freshmen, 20 sophomores, 20 juniors, 20 seniors. Okay, so I'm picking people from every single group. I'm going to pick randomly within the group, so I'm going to pick 20 random freshmen. I'm going to pick 20 random sophomores, 20 juniors, 20 seniors. In each group, I'm picking randomly, but I am making sure to pick from every single group. So that would be a stratified sample. Okay, so that's stratified. I have to pick from every single group. Okay, if it's a cluster sample, then we're not going to take from every single group. We're only going to take from some of them. So let's say I just wanted to pick from freshmen and juniors. I only pick like 40 from freshmen, 40 from juniors. That would be cluster. Or if I just took from upperclassmen just 40 juniors, 40 seniors, that's cluster. Anytime I'm separating into groups but only taking some of them, that's a cluster sample. So that's the main difference between stratified and cluster. Stratified takes people from every single group, and a cluster sample only takes it from some of them. Okay, so that's the different types of sampling methods. Alright, the last thing we have to talk about before we move on to some actual examples is the difference between a biased sample and a representative sample. And that has to do with what we were talking about earlier with the fact that a sample really should be a small version of our population, because if it's not, it really has the opportunity to be biased. So a biased sample does not represent the population. Okay, and that's because maybe it like doesn't have a very wide variety of people, or it doesn't really count as like a smaller version of the population. Maybe we're just picking from a certain type of person in the population. That would be a biased sample. So with our sampling methods, a lot of times, not always, but a lot of times the ones that are going to be biased would be self-selected, because if someone's volunteering to be part of a sample, it's probable that they're going to be pretty passionate about whatever you're talking about. So that's going to be biased. A convenience sample could be biased depending on the situation. And a cluster sample as well, because the cluster sample does not represent every single group within the population. Okay, a representative sample is the opposite. It does represent the population. Okay, because it does include a wide variety of people. We kind of have a little mini version of our population represented as the sample. That would be a representative sample. Okay, so the ones that typically, again, not always, are going to be representative are systematic, simple random sample, and stratified. Okay, and remember, cluster and stratified are very similar to each other, but cluster only takes from some of the groups, which is why it would be biased. Stratified is going to represent every single group in that population. Okay, so let's look at these examples. The first one, we're in the NFL. We want to know how players feel about some changes to the rules. So they're going to ask a sample of 100 players. They're not going to ask every single player in the NFL. Okay, so we have these different scenarios. We have to figure out the sampling method and if it's biased. So the first one, they choose 100 players, the first ones who volunteer. Volunteer is a key word for us. If they're volunteering, they're picking themselves to be part of the sample. That means it's self-selected. Okay, then those players are probably pretty passionate about those rules. They're probably going to be pretty biased. So this is going to be a biased sample, because those ones that are self-selecting themselves are part of a small part of our population. Okay, the next situation, the officials randomly choose 3 or 4 players from each of the teams. Okay, so this kind of has two things going on. First of all, we're separating it into teams. That's groups. So if we see that our population is being separated into groups in any way, we can automatically decide that it's either cluster or stratified. And then we just have to figure out, are we taking from some of the groups or from every group? So if we look here, from each of the 32 teams, that's got to be stratified because it's from every single team. So that's going to be stratified. And since we're going to be having some players from every single team, that's going to be pretty representative of the entire group of NFL players. So this one is going to be a representative sample. Okay, and then the last scenario, if we have a computer randomly generate a list of players from a database of all players, okay, we have some few keywords going on here. First of all, we're looking at all the players, we're not grouping, so it's definitely not cluster or stratified. Okay, so it's going to be one of the other ones. They're not picking themselves, it's from a computer randomly generating. That's not convenient to me. I'm not walking in and seeing who's in a certain place at a certain time. Okay, it's not following a system because it's random. Okay, so this is going to be a simple random sample. Okay, something to be careful about though, just because you see random doesn't mean it's going to be simple random, because look back in this one, it still said randomly choosing. Okay, but because we have this thing where we're separating into groups, that's what tells us it has to be either cluster or stratified. So be careful, just because you see randomly does not mean it's automatically a simple random sample. You have to kind of look at the entire situation, make sure it's coming from everybody in the list of the population. Okay, and this simple random sample is going to be representative because, what the heck? Representative. It is going to be representative because if we're randomly picking people from the entire list, we're going to get a wide variety of people. Everybody has the same chance of being chosen from the list with this method. Okay, next example, administrators at your school want to know if students think that more vegetarian items should be added to the lunch menu. Okay, so same thing, we got to figure out the method and if it's biased or representative. So this one, the first one, they survey every 25th student who enters the cafeteria. Okay, so we're getting all the students in there, but we're picking every 25th one. This is not a random picking. This is not grouping of any sort. We're not making it convenient to us. We're not asking them to pick themselves. If we're following a rule like this, that's systematic. Okay, so this would be pretty representative because we're going to get a wide variety of students. Okay, the next one, administrators survey the first 50 students who get in the lunch line. Okay, first 50 students, I'm just saying, all right, the first 50 people in this line, I'm just going to ask them. Okay, that's very convenient to me. So this is a convenience sample. Okay, I'm not picking them randomly. They're not picking themselves. I'm not splitting it up into groups, so this has to be a convenience sample. Okay, I'm not really following a rule. I'm just saying, if you're here, I'm going to ask you. Okay, and this is not going to be representative of our sample. The biggest reason why is it's talking about people who go to the lunch line. Okay, the first one talked about people who entered the cafeteria. So we have all sorts of people. They could bring their lunch or they could be buying their lunch. In the second one, they're getting in the lunch line. So these are people who are already fine with the lunch choices. Okay, and if we look back at the situation, we're trying to figure out if they want more vegetarian items on the menu. So if we're asking people who are already making it a habit to buy their lunch, they're probably fine. They can find stuff that they want to eat in the cafeteria. So this is not going to be very representative of the entire population of the school. Okay, and then the last one, very similar to the last one on our last example, randomly generated list from the master list of all students. So if it's all students, I'm not grouping. That's not cluster or stratified. Okay, if they're not picking themselves, I'm not saying, oh, you just happen to be here. Okay, and I'm not following a rule. It's a randomly generated list. So again, this is going to be simple random. And again, it's going to be representative because all sorts of students are going to get into that sample. Okay, and then our last one, we have a local newspaper conducting a survey. We're trying to figure out if adult residents of the city think the use of handheld phones while driving in the city should be banned. So our population, we're looking at all the adults in the entire city. Okay, and so when we look at these sampling methods, the first one, newspaper sends a text message to a random selection, so we have it randomly, it's not following a rule, of subscribers to the newspaper whose cell phone numbers are listed in the paper subscription database. So there's a couple different ways you could think about this. If you're thinking about the population being everyone in the city, okay, the fact that we're only picking people who subscribe to the newspaper and who put their numbers in there, there's a few ways you could think about this. One is you could think about this as two groups. You have a group of people who subscribe and have their numbers in there, and a group of people who don't subscribe. And we're only picking people from the group that subscribes, but we are picking randomly in there. So if you're thinking of it that way, you would say cluster sample. Okay, or you could, if you kind of thought about the population as people who subscribe to the newspaper, then maybe you would think of this as a simple random sample, because they're just randomly picking people from the list of their subscribers. Okay, it kind of depends on how you identify the population, and some of these kind of can have multiple answers depending on how you think about it. Okay, but either way, regardless of how you classify the sampling method, this is going to be a biased sample, because if we're looking at this, we're trying to figure out if people in this city want to ban cell phones while they're driving. Okay, and if we're just texting people whose numbers are in the database, then that's really going to not be very representative of the people in our city. So either way, this is going to be a biased sample. Okay, and then the second one, using the 10 neighborhoods into which the city is divided, so we are dividing into groups. Automatically, we know this has to be systematic or cluster. Okay, we are randomly contacting 100 people living in each of the neighborhoods. So because we have this word each, that's what tells us it has to be systematic, because we're not just taking from some of the groups, we're taking from all of them. So this is systematic. We are going to represent people from all sorts of places in this city, and in those places we're randomly contacting people. So this is definitely going to be representative of our sample, because, or of our population, because we're going to get a wide variety of people to represent just like a tiny version of what our population would look like.